And recording starting. So, some announcements. Well, one big announcement. Helm Summit is coming up next week. I believe it's Wednesday and Thursday in Oregon. Hope to see a lot of you guys there. I'll be there. I know Matt will be there, I believe. I'm not sure if Anand is going to make it, but a lot of the community will be there. It should be an exciting discussion, both about kind of where we're at and where we're going in Helm 3. So moving on to updates. For sets, we're really just working right now on moving stuff over to the V1 API. There was a PR by Matt Liggett that enabled the storage format to V1 by default. And we want to try to get conformance done by the end of this release. I don't really have any updates on jobs. Does anyone else?
Okay, for jobs itself, I don't have any updates. There's one PR for cron jobs that I would like to get merged for 1.10, which is about manually initializing jobs out of a cron job. So that's the only thing that I'm hoping to find sometime this week and push it over the hump for 1.10.
Cool. Okay. Now we have some time for demos, and the first one scheduled is Kubi Toolkit. Radu, are you there?
Hi.
And did I pronounce your name correctly?
Yeah. The name is Radu. Hi, I'm a technical evangelist at Microsoft. And let me just share my screen. Let me know when you can see it.
We can see.
Okay. And basically, I'm gonna present Kube Toolkit. It's basically a toolkit for creating basically tools for Kubernetes. Just 1 second so I can share the actual link. Yeah, so there it is. Yeah, so when I say tools for Kubernetes, let's have in mind kubectl for one moment, and for example, Helm. So these are usually CLI components, usually written in Go, and they talk to a component on your Kubernetes cluster. In case of kubectl, it's the API server. In case of Helm, it's called Tiller. And essentially, they talk, the API, the component that sits on the Kubernetes shouldn't expose any public endpoints, and they communicate over some sort of protocol, HTTP or gRPC or something else. If we talk about these tools, they usually have also some web dashboards. If we talk about kubectl, there's the Kubernetes UI dashboard. When talking about Helm, there's Monocular. And the problem that usually appears is that, for example, Helm does its communication over gRPC with the Tiller server. And right now, there's no gRPC web public that you can use. So most of the times, you end up having to keep and sync APIs for gRPC and for HTTP for your web dashboard. So kubectl is basically a toolkit for building CLI components with a Kubernetes server and a web dashboard. And it's basically packaged so that you can start working on your tool just by forking this repo, renaming your tools, adding your methods, and basically just deploying it. So right now there's nothing on my cluster right now. And basically, it's a self-deploying tool. It uses the Kubernetes API to deploy itself. And right now, it created a pod with 2 containers. It contains the server component, the client you have locally. You can either make it, build it, or download it from a GitHub release. And basically, at this point, It creates an authenticated tunnel using the Kubernetes API back to the to your server, and it does whatever your service does. You can also do server-side streaming because it's gRPC, and these are basically implemented so that you can understand how to extend these commands going forward. As I said, there's also a web dashboard. So there's a proxy command that starts a proxy on port 8081 locally, and basically it exposes whatever you have defined in your service. Now, how it does that? So as you know, this is the protobuf for your gRPC, and it uses a project called gRPC Gateway that basically creates a proxy in front of your gRPC server that translates JSON from web requests to protobuf for your gRPC server, and the other way around for the response. And basically you say that for this RPC, for this gRPC method, I want the get method mapped to /API/version. And it will automatically generate, based on the protobuf, it will generate client, the gRPC client that you'll use in the CLI. It will generate the gRPC server, and it will also generate the gRPC gateway, the proxy that will stand on front of the gRPC server, and it will also generate a TypeScript client for the Angular dashboard that you see right here. So essentially, all you have to do is update your definitions, your API once, and all your clients, all your APIs, all your servers and clients are in sync. It uses, as I said, the protobuf compiler to also generate the gRPC gateway and the Swagger definitions, and it uses Swagger CodeGen CLI to basically create the TypeScript client. So, as I said, fork this repo, and you only have to add your commands here. You add your command here, you implement whatever server method you have, add a Cobra CLI command, add an Angular dashboard component, and that's it. There's examples on how to do both of those things, and you can basically emulate the version and proxy and stream commands that are implemented in web and in CLI. Work in progress, first of all, is integrating with Draft so that you can easily iterate through your builds. State management using etcd, it's in progress, I already started it, and also using config maps. RBAC and SSL, help wanted if you want to contribute here, and if you have any sort of feedback, I'll be glad to discuss it with you. So just fork it, add your service, and just make client and make server, and just init, and that's it. If you have any questions, I'll be around here. Thanks.
Thanks, that was cool. Does anybody have any questions?
One in chat. It's not very clear. What is the kind of example where this could be useful?
So essentially, if you think of if you want to create a tool like Helm or like Draft, this is basically a starting point, so that you don't have to do all the plumbing in connecting your gRPC client and server and connecting to authenticated tunnels back to Kubernetes. So basically, it's just a starting point for you to create Kubernetes.
Thanks.
So, yeah.
I had a question.
Yeah.
Kubernetes has an auth mechanism, and when you use kubectl, it uses the kubeconfig, the credentials. If you have a server running, the gRPC server.
Nope.
Oh, sorry.
That was not to you, Phil. Continue going.
Okay. Does this have a mechanism to forward those credentials to the server, so the server is impersonating the end user, or how does it?
Essentially, it uses the kubeconfig, basically.
So the client forwards that to the server, and then the server impersonates that user, or how does it use the kubeconfig?
It's basically using the kubeconfig directly to use the Kubernetes API. So if you want to use the Kubernetes API in Go, you need the kubeconfig to do it. So this uses exactly that.
I mean, so let's say I write a service that like creates pods.
Yeah.
Right? How does that service know that I, as an end user, can create pods? Like, who is it running as when it creates those pods?
So essentially, if your server-side components creates pods, if you're inside the cluster, you're already authenticated, basically. So it's you would use in-cluster authentication.
I see. So it's running as its own privileges.
Yeah.
Okay.
So I think Phil's question pertains to a lot of times with Kubernetes, a user has specific RBAC permissions defined in their kubectl or in their kubeconfig. And a lot of times we use the pattern of impersonation in order to carry the privileges of a particular user to the service that is performing an action on behalf of them. So imagine if I did have something like Tiller where it would create pods or stateful sets or deployments in particular namespaces at that. One model that we tend to use is any user will be impersonated by the command line and then by the server, and the server can take whatever actions that user has permission for. This seems like when you install it, the model is you install it into a namespace with the permissions that it should have, and it doesn't use impersonation. It just has its permission set and can perform whatever actions it has permission to do.
As of right now, yes. One issue on going forward is using RBAC for that. But right now, it just uses whatever permissions are in that namespace.
Cool.
And just for curiosity, when you mentioned that there is some existing work that uses the impersonation on the in-cluster, are you referring to just in general a security theme that we like to carry, or is there something specific project in Kubernetes that you've seen that done successfully in?
It's just a pattern that we like to try to carry. And to be honest, I'm not on the security side. Like, I get why you would want to do impersonation, and I've seen it used successfully as a pattern before. Installing with the necessary permissions and not impersonating is also a valid approach, depending on what your exact concerns and needs are and what your threat model is, right?
Yep.
Just wanted to kind of clarify that, like, what Phil was talking about is, on one hand, impersonation is one way that we ensure that a user has permissions rather than a service having permissions. But there could be valid models where you want the server to have a specific set of permissions and that's it. And then the user can access that server and it doesn't really need to impersonate.
Yeah, so an example of this is like, if I have control and I wanted to move stuff out of the client into the server, for all the various reasons you might want to do that using this tool. When it runs on the client and I create deployments, it's using my credentials to create those deployments, right? But then as soon as I move it into the server, it's not using my credentials anymore, right? And so I might be able to escalate privileges or do other weird stuff.
And one of the, I don't know if you want to call it issue, but the current design of the core controllers that running Controller Manager, they all have a specific set of RBAC that's pre-installed in the cluster, which okay, it's one way to do things, but maybe impersonation might have been a better idea go forward with that, but it gets a little bit harder to do.
RBAC is, for this tool specifically, is one area that I'll welcome any help that anyone wants to contribute. So yeah.
I just have one piece of feedback. I'm just looking at the README. And it seems like the assumption is that this is for somebody who appreciates the model that Helm and Draft implement. However, it doesn't describe, it doesn't give any reason to why that model may be good or whatnot. So if you could outline that, that would probably help the users, because right now I'm looking at it, it's like it says, well, if you like to do something like what Helm does, well, why would I do that, right?
Okay, yeah, thanks. Appreciate the feedback.
And I mean, yeah, maybe outline comparison to other approaches.
Okay, yeah, thanks a lot.
All right, thanks, Radu. if there's nothing else immediately, we can follow up later if we want to discuss this more in chat. I'd like to give Michael Hasselblaus, I believe from Red Hat now, a chance to do kube.sh.
Thanks a lot.
All right. Thank you. Can you hear me okay?
Yeah. Hey, Mike.
All right. Hey. All right. I'm going to share my screen. Everything. All right. Can you see my screen?
We can.
All right. Perfect. All right. Thanks a lot for having me today. So I want to show you Kube-Dash. And before I'm going to do that, it's a very, very quick demo. A bit of the motivation behind that. I believe that we should be able to interact with a Kubernetes cluster in the same way we're interacting with our local machines. If you think about how do you launch, for example, binary, you just type in the name of the binary in your shell, hit enter, boom, off you go. If you want to see what's running on your box, you enter PS. If you want to get rid of one of the processes, you get the process ID and say kill process ID. Question is, why don't we have that for Kubernetes? In Kubernetes, we have to learn all these concepts, parts, deployment, services, and so on. And we have kubectl, we are writing YAML files, and so on and so forth. So my goal with Kube-Dash is to provide the 99% of people out there the same interaction that they have and know from the local machine, from the shell, bash, or whatever, for a Kubernetes cluster. Okay. Let's have a look. Probably need to make that a little bigger. Can you see the terminal here? Well enough. Okay, cool. So launching Kube-Dash here, and the first thing you might notice here is that as prompt, you actually see the context and the namespace you're operating on. There are a couple of built-ins here. Some of them operate locally, some of them in cluster. But for now, let's do exactly what I just said in Kube-Dash. The very same thing. In this case, I'm going to use a Node.js script. So I want to be able to say Node, so that would be the interpreter, and then test.js. Now, if I do that, you see in blue, I don't know if you can really see it well, a single pod is created. That's effectively what's happening on the local shell as well. And this would be interactive, and it's just essentially a web server that reacts. But we don't really want that. We want to have a oops, I screwed up there, sorry. Just that one here. We want to have a long-running process, so nothing running yet. Okay, so I want to be able to say node test.js and put it in the background. Okay, I need to go into test cases. Now I'm there. So what happens now with the ampersand is essentially the same that happens in a local environment. It puts the process in the background. Yeah, now of course I need to clean up first. That's the demo effect. Good boy. So if I have a backtick, then I can essentially directly do the kubectl commands. Delete. So that's not part of the demo, that's just me screwing up. Delete, deploy, and then this one. And probably also a service created already, yes. So it's just, all right. Back to what I actually wanted to show, and that is, so we want to launch this test.js, this, if I can actually show you how it looks like, it's not that fascinating. It's really just a very simple HTTP server that reacts with hello from Node.js if you hit root, right? So let's launch that. So what it does under the hood is it shells out to kubectl, creates a deployment, creates a service, and again, I have a problem there because I didn't clean up everything. That is a deploy. Okay. So the actual demo would be like 2 minutes, and because I screwed up, I need to do all. Okay, delete, and probably some part is hanging out there as well. Yes. Delete part. This one here. And I think we should be good. Just a moment. Waiting until the garbage collection kicks in. Come on. So what we expect to see once I do this again is a deployment, a service, and the service name would be derived from the name of the binary, or in our case, this JavaScript. And then I should be able to curl it, right? Let's see. All right, I think I need to use the hammer for that. Simple. Okay, let's delete everything that I've labeled with gen cube dash. So once more, how are we doing with the parts? So once this part is gone, I should be good. Okay, node test JS ampersand. Double check. I'm just running Minikube here. Locally. Very, very soon. Sorry for that. That's yeah, my fault. I should have not started with the interactive one. One shot. Come on. I might have replicas of them. It's really just that. All right, now finally. Deployment, service, and then so if we do PS now, we see that there is a cluster process running from the source test.js that is using exposed to service that is called test, which is derived from the source. Then you can override that, you can override the port, you can override many other things through environment variables. And now if we say curl test, we should hopefully get hello from Node.js. And that curl is actually running in a pod, one-shot pod in the cluster. And yeah, that's pretty much it. And again, apologies for screwing up the demo. Any questions?
Did you say that the curl is running in the pod that was launched, or it's running against the service?
That's right. It is running in. We look at the architecture, it's probably easier to understand. So if you look at the architecture, what really is happening with what Kubedash really does, it's heavily shelling out everything to kubectl. So you can work with different clusters. For example, say clusters. And then I get all the context. Then I could say, use whatever context here, so you can switch between different contexts. And within a cluster, I have namespaces, obviously, that's the normal construct, and then within these environments, so that you can essentially launch different things in essentially a bunch of labels for the resources created. And the built-in command curl, essentially, technically, it's simply launching a pod, so we can enable debugging, so debug. And if we then do curl again, you would see that is the underlying kubectl command that it's actually launching. So it's in a way you could use Kubernetes also to learn kubectl. But my goal really is to make people not learn kubectl, but to just use their release cluster like they would do in a local machine or local shell.
Thanks.
Any other questions?
There's some support for iterative development as well, right?
That's correct. There is actually, thank you, Emiko. There's actually a, I've put together, well, I'm actually working on a Katacoda scenario, which is not quite ready yet, but there is a recording there. So it already works, but so if you want to check out, I'll just put it here.
Michael, who's your target audience for the shell primarily? Administrators, developers?
So first, it's not for production. It's definitely not for production. I don't want people, like, you can use it in production, if you want to more easily interact with a cluster, but it's really for prototyping, developing quickly. Imagine you have 2 or 3 microservices and you were working locally with one, a new one that depends on others, is called by others. And you really want to quickly iterate, and at some point in time, you say, okay, now I run it through a CDC pipeline, put it, the container image somewhere, and then it actually goes through the normal life cycle and will be pushed into production. It's really for people, your average Joe Node or Python or Ruby or whatever programmer that has access to a cluster, to a Kubernetes cluster, but doesn't want to or cannot or whatever learn Kubernetes concepts, kubectl, YAML files, and so on and so forth.
Cool.
I'm not saying I'm there yet. I'm just saying this is a suggestion for a new interaction paradigm with Kubernetes.
Cool.
I think that's very interesting. I was also wondering about like the syntax. Is this sort of on top of Bash, or you wrote some kind of command interpreter of your own? Yeah.
Right. So underlying what I'm using, and I'm not quite sure if I will continue to use that, but currently I'm using the readline package. So Kubernetes is written in Go, and it's using the readline package, which more or less is a shell. So you have autocomplete, you have a history there, and so on and so forth. And then the rest is shelling out to 80% kubectl, and then a few things like LS and PVD and PWD and stuff like that. That's just local there, but essentially, yeah.
Okay, so just commands and like no control structures or anything like that.
No, it's entirely stateless. All the state is in the Kubernetes cluster, represented through mainly labels and annotations.
Interesting. Yeah.
Yeah. Okay.
Because it feels a bit like Bash, so I wonder how soon people would want to do things they're used to doing in Bash.
I already got a lot of cool feedback in terms of make it scriptable. I'm using that now to do end-to-end testing. There are many more things that still not work in terms of interactivity. That you launch something and then you actually want to interact with that. So I appreciate help in all forms of
because I was at some point I was looking at some of the shells written in Go, and that's an interesting territory. But I've been hearing more recently then there is this Python-based project called Oil that sort of is trying to write a new shell, but they are trying to write a new shell.
Oh yeah, Oil shell. Yes.
Yeah. So maybe
do you want me to talk into writing Python now?
No, I don't know. I don't know, Michael. We can talk offline.
Yes.
Okay. All right. Thanks again, Michael.
Okay. Thank you.
Now we're scheduled to do some stand-ups. I believe we're starting with Helm. Is there anybody from Helm who would like to give an update?
If nobody else wants to, I can jump in. All right, the big news for us is 2.8.1 came out last week, and the Helm Summit is next week. So we're between the two. Most of the core team is working hard on getting the preps done for the Helm Summit out in Portland. We're excited. We have a pretty good sized crowd and some excellent speakers in the lineup. And public thanks again for all those people who jumped in to get the bug fixes in for 2.8.1. I think that's all I got.
Cool. Thank you. And the charts. Anybody from charts have an update?
I don't think there's anything particularly that needs mentioning, but just a reminder that we have the charts chat every other Tuesday, and actually we also have a new charts office hours call, which is on the other week. So on one week we'll have the charts meeting, and then the other week we'll have the charts office hours. So the charts office hours is tomorrow. This is a good place to come if you have PRs that are outstanding and would like to, talk to some maintainers and try to get them merged. Everyone should have an invite to that call if you're in the SIG Apps mailing list. So yeah, come by.
Cool. Monocular?
Oh yeah, I suppose that's me also. So I don't have a major update on Monocular, but on the Cube app side of things, we're working pretty heavily on a new UI, and hopefully that lands in the next release, which would be 0.3.0.
Cool. Okay, Chart Museum.
Hey, hi. We got some cool feature last week where you can anonymously grab index YAML, but put basic auth on the API routes. So that's pretty nice. Also, this is more news about me, but also kind of for the project. I'm going to be working with CodeFresh on extending their Helm support. So as part of that, they're letting me spend a lot of time working on the Chart Museum project. So I expect some cool things in the near future.
Cool. And I guess Phil wanted to talk about Kubi Builder. We have this scheduled for a demo in 2 weeks, I believe. But Phil, did you want to say something now?
Yeah, sure. I'll just say that I don't know if there's extra time at the end, like would it be possible just to do a demo now quickly?
Let's see. All right, but there's one discussion topic we have, and if we do have, I want to give people a chance for other discussion. If we have stuff to talk about, if there's, no other open discussion topics and people are amenable to it, then maybe we could sneak it in. Does that sound cool?
Yeah, sounds good.
Okay.
So I'll just say I'm working on a toolkit for building Kubernetes extensions and APIs and ecosystems. And so that's, if you're interested in that, then come talk to me.
It's pretty cool, I gotta say. So basically it generates extension API servers and all the tooling around a controller for you from a CRD. But we can talk about it later, and Phil's gonna give us an awesome demo for it at some point. If not today, then 2 weeks from now. Okay, so one discussion topic. So the application object CRD controller that we have a cap out for. There's, number one, I think some confusion that, even between people who've been in Kubernetes for a long time about the KEP process. So to be clear about one thing, moving something to an accepted state doesn't mean that that proposal is accepted. It means that the SIG has accepted the idea that we're going to talk about it and iterate over it. So this is very different from the previous feature repo process where you put in a feature, you put in a design document. When the design was accepted, that's what you're going to go implement. And that kind of is what it is. And then at the end of the feature, like when you're trying to merge in for the release, if what you implemented meets the design constraints that were outlined in the design proposal, that's, kind of like, okay, we should definitely merge this. With the KEP process, apparently what we're supposed to do is if we've decided we want to do something, we accept the KEP and then we iterate over the KEP until we get the design to where we want it to be. And this can be done in conjunction with development. But ultimately, at the end of it, you should have a KEP with a design that meets what's implemented. We're basically piloting this process right now. The only other place this is going on is in the controller manager working group. And if you look at their KEP, it's a lot more high level, a lot less detailed. It doesn't propose a lot of design. So my question is, basically as a SIG, do we feel like this process is working for us? Is there a lot of confusion around it? What could we improve here?
And Kenneth, do you want to start us out? It seems like you might have some suggestions here.
No, I mean, honestly, my only thing is, so a wise man once said we should use process, but only as much process as is useful and not a drop more. That being said, we shouldn't diverge from I don't think we should as a SIG diverge from whatever processes are going to be prevalent across the community in general. But it seems like we have an interest in doing something here, and I just want to see what people think the path forward should be. Should we, as the KEP process says, accept what's out there now and continue to iterate on that? Should we maybe break it up a little bit more, for instance, and then because I imagine what will happen is there are many people who are very interested in app metadata, for instance, and what that should look like. And I imagine that could be iterated on very rapidly, and whatever we come up with as a design right now is probably not going to look like the end result of it. I think the life cycle of the application object is another thing that we could iterate on, and maybe independently of the metadata. So I'm just wondering, as we move forward with this and we set up a repo, does anyone else have any ideas what it should look like? What do you think, what does our SIG think works best for us? Or they're not strong opinions on this?
I have a question kind of about the process, because I've been following the KEP, and I think I think the application object is an interesting idea, but it seems like the community is, mixed about whether it should be added in as a part of the core or something separate. So the question is, if we kind of walk away from the KEP and just start implementing something as like a CRD with our own set of controllers and whatnot, is there an opportunity then to bring that back to core, or does it forever exist as some sort of, just extra project or whatever?
So I think as it stands right now, I think we have broad agreement that this is something that should be done as a CRD. If something is done, we should not do it in core. We should do it as a CRD. And if it's proven to have value as a CRD and as an ecosystem component, then we consider bringing it back into core later. You can, if you build something, so like to give a little bit of history, deployment started as deployment config in OpenShift, and it was developed as something external to Kubernetes before it was contributed back into the core workloads API. So there's definitely a way to do that. Now, on the flip side of it, looking at it from the perspective of a SWE, you're going to spend significant software hours building it outside. You're going to spend more SWE hours moving it back in, and you probably are going to end up with two separate things, one in core and one as an extension, if you choose to move it back in, that you're going to have to support going forward. I think ultimately what the feedback that I got from the community at large is that if we need to be able to use extension mechanisms and we can't put everything in core, and as we move forward, we should prefer doing extensions. And then if we prove that it really has value as an extension, then moving it into core. And we should focus our energy on easing the path to developing extensions as opposed to not developing an extension because we have questions around how do you migrate it back in, or how do you do, for instance, internal versioning for CRDs and use CRD extensions where possible. And then you can bring it back into core later, but that's an entirely separate thing.
I mean, given what you're saying, it almost seems like, you know, it'd like drop the cap and just start working on it.
Well, but here's the thing, right? Like, so as a SWE at Google, I could go grab a bunch of people and we can go off and just iterate on something real fast and put it out there, which is fine to bootstrap something, but I really wanted to get input from other people in the community and from other organizations that, you know, from the people who are building Helm or have built Helm, from the people who are doing Compose, from people who are doing the CLI tooling and the UI tooling. And I don't want to go do something in isolation. I'd rather get feedback from the community and build something together if there's interest in doing something together. If ultimately the feedback is like, that's not what we want to do, that's fine too. But I feel like that's the antithesis of the feedback I'm getting. It seems like we all want to do something and we all kind of want it to converge on something at least similar and compatible, but there's, you know, no other process for doing that other than setting up a cap as it is. Now we could just open up a repo. That's something we could do, but how do we keep that from digressing to just implementing random things without actually discussing it with each other and making sure we're building the right things for the community at large?
Well, doesn't this tie into what they're trying to build with the decentralization of the projects anyways, and having more SIG maintained software? So does that not fit?
For sure. And I mean, ultimately, I think if we're going to do something, what'll happen is we're going to put it in a SIG maintained repo. So I think the question, and maybe I'm not phrasing it well, the question is, if we do that, how do we want to manage our software in our SIG? Do we want to do caps? Do we not want to do caps? Do we want to do caps some of the times? Do you think there's a benefit to doing a cap? Like this is something that we can follow guidance from the steering committee on up to some extent, but we're basically piloting the process.
But when you talk about caps in this perspective, are you saying, branch a separate repo to start doing this like work on the app object, and then accept caps towards the app object repo or whatever? Is that what you're talking about?
Yeah.
Okay. I mean, I don't see what the problem is doing this in like why not take it in a separate repo? Don't go fast, but go slow so that we make sure to have time to get, input from everybody. And, whether it doesn't have to be as complex as a cap, but I mean, just simple, specs to improve the application, just put together a process whereby, people can get involved in a collaborative way. If the goal is to go slowly and make sure we get everybody's input, then just let's go slowly and get everybody's input. Let's not put the pedal to the metal.
Well, I mean, here's the thing. So that's kind of the exact feedback I'm looking for. If we feel like the cap is a clunky process, we could just set up issues on GitHub on the repo. If people would rather do it that way, we could have a separate issue for application metadata, application lifecycle, so forth and so on. We could offer designs that way. That is one path to move forward too, right? And it's not really about how fast we move. I think we can move as fast as people want to move and people are comfortable with. Ultimately, adoption is the test of how well you're doing, right? So when you start seeing people pick it up to use it, that's when you know that you've got something relatively solid. It's just I think there's definitely a lot of let's hold the brakes on core objects right now, right? So I think there's intentionally a lot of process surrounding adding new things to core and making sure that whatever we're doing, we keep the core API stable. The cap process is kind of the only thing we've got going forward other than the prior process for design, proposal, feature requests, so forth and so on. And there is definitely in the community some interest in trying to maintain some level of consistency across ecosystem projects so that a developer who comes and sees this or wants to go work on Helm or wants to go work on Kubernetes core it's not a completely separate process where your mind is just blown and it like you're so unfamiliar with it, it makes no sense to you, right? So, I mean, before anything gets done, I just wanted to try to get feedback about like when we start doing our own repos as a SIG, how do you guys want to do it? Like, is there like a strong preference to not using caps and to using features and issues in GitHub and using this like a more standard get flow? Also, like for Kubernetes, we build everything off of master. Would we as a SIG be more comfortable doing things like using feature branches and release branches as opposed to trying to push everything into master simultaneously? Like the Kubernetes process is stood up because Kubernetes is a very unique project that gets more PRs than pretty much anything on GitHub. But I don't think everything in general that we do as a SIG is going to have those same constraints, right?
I think part of the challenging issue here is that the KEP process that's defined in the document that Adnan dropped in does not feel like it fits the process we're trying to do. The workflow states don't, to me, make any sense, right? You have accepted, implementable, and implemented. This does not sound like a process that's designed to encourage, say, a standard where multiple people could implement the same thing, right? Because essentially, according to this process, if you implemented your CRD, we would have to jump automatically to the implemented status, right? Or, for example, if
that's a valid point.
Yeah, so for example, if we have two different people who are trying to implement the same thing, it's unclear which of these states works. So like the process doesn't seem to follow the same sorts of processes that, say, PEP or RFC or other standards like state flow does. This seems to be intended to describe only a core piece of the Kubernetes infrastructure. So my preference would be, because I see a lot of value in the whole KEP idea, or at least in the way PEPs and RFCs work, where you could say, here, I'm going to try and specify something. Whether or not there's an implementation is irrelevant to the specification. The specification is just an attempt to gain clarity on a particular tool, format, method of doing something or something like that. And then whether or not these get implemented is really left up to whether or not other people find them useful. So you can look through the registry of PEPs, for example, and see ideas that were formalized but never adopted. Likewise, if you really want to see this in action, go look at RFCs, right? There are bazillions of them, of which some of them were utter failures, right? And people specified something very carefully and then tried to build it and it didn't meet their needs and so on. But it's a successful process because now you can look back and say, oh, here's an RFC for somebody who tried to do something similar to this. It failed, right? So I like the idea that you're trying to push with the KEPs. I really think that's the way we ought to go. I just feel like the KEP definition itself is loaded with a major ambiguity, which is whether we're describing a feature request for Kubernetes core or whether we're trying to agree upon a standard for something. So I liked the way you were handling things with the application thing. I too was like startled when it jumped into the accepted state, and I'm like, wait, what? I thought we were still discussing this, but now I see it really has more to do with the sort of what I think are mislabelings of the states there. So,
right, like I mean, to me, accepted and you know, Matt Farina was confused about the same thing, right? He's like, accepted means this is what you should go build, and I think one of my concerns is that that's exactly what it means for the design proposals and the community that we have right now, and that ambiguity I could see causing a lot of confusion to people who do a lot of work in core, right?
Right. Whereas apparently the state that we confused it for is labeled implementable, which doesn't necessarily intuitively ring that this was a vetted. It's not a word that we tend to use to describe this was approved by a committee or whatever.
Yeah, I mean, implementable and generally means you can do it, not that it's what you should do, right?
And your spec is definitely implementable, but we don't know if it's in the state that we all agree that it's the best way to implement something. So
correct.
I mean, that's why the sort of the explanation of the state flow there makes it sound more like describing the progress of a feature request through Kubernetes core and not so much like your typical standardization process or something.
Would you perhaps mind giving that feedback on the KEP process itself? Because I think what you said is really cogent and really just kind of might be useful to the people who are trying to implement the process in general, in terms of feedback for them.
Sure.
Does anyone else have any other thoughts?
So I think the other thing to mention is that the application kept as it is, I think, is a little bit large and it covers a lot of different things, and it's a little bit hard for people to give feedback in current state. And I think what would help is if there were some, maybe even smaller proposals which cover specific things like, what should the metadata look like? How should the controller react? And these are all kind of different things, and I'm sure different people have different opinions on. So I think splitting up that single proposal into multiple smaller proposals might be a good bet. And I don't know that we can do that with the KEP process. And so for that reason, it might make sense to do that in our own repo.
That makes sense too. Okay, if nobody's got anything else on this, is there anything else we want to discuss with the last 5 minutes?
Do you want a demo of KubeBuilder?
Can you do it in 5 minutes?
Yeah, if I can get it that quickly.
Careful. Be very careful what you achieve in 5 minutes.
Are you sure you can do it justice in 5 minutes?
Oh, no. It would take me like 2 hours to do it justice because there's so many hot features, but
humble much?
Sure. Okay, let me just give you a quick thing, and then I can in the 2 weeks I'll do a little more detailed. But real quickly, KubeBuilder is supposed to be an SDK for building APIs. Starts out, so I have an empty Minikube project here. You can see, and so the first thing you do is initialize a new project. So this is just going to initialize a new project, and it prints out like, here's all the stuff I'm initializing for you, and creates all these packages. And then it says, go ahead and create a resource. So I'll go ahead and create a resource, and then it prints out, okay, here's all the files I'm generating for you. And you give it like the group and the version and the kind of the resource. And then it's going to go run all the code generators for that resource. You have a nice client and informer and all this stuff. You can see it generates both a type file and a controller file, as well as the test files that go with these. So I'm just going to pop one of these open real quickly in another tab while it's generating the code for you. And you can see it creates this thing where it adds like these all-important annotations, like gen client and deep copy and open API gen and all this sort of stuff, so that you don't get those wrong, and gives you a nice little place to drop in your schema here. And then I'll just pop open the controller too. So the cool thing here is it generates a full controller for you, and all you need to do now is implement this reconcile method. And it gives you a client and everything to talk to Kubernetes, and so you don't have to do any of that stuff. And it just prints one out for you to reconcile. And then real quickly, you may be interested to see that, like, everyone knows tests are important, but they're kind of a pain to write, and getting started is probably the hardest part. This gives you a fully functioning test that checks that the reconcile loop is run with the right controller or with the right keys. No errors occur when you create an instance of this. And so it just gives you a little slot that says, okay, as you add logic to your controller, just go ahead here and check that the controller did those things. And this brings up a control plane using a test harness written by some of those folks at SIG
Phil, we're not seeing the code.
Oh my goodness, that's horrible.
We can see your terminal.
You can see my terminal, but no, oh, not the code. Oh, because it's, okay, got it.
You locked it to one screen, I guess?
And I locked it to one tab in the terminal, which is weird. So it's finished generating the code. Let me just pull this up. Sorry, can you see it now?
Yep.
Okay.
Yep.
So you can see here, this is what was generated. And then you add, it says like insert your code here. That's what I was talking about. And then let me show you the controller again quickly. So this says the controller that's been created for you and has this reconcile function here. And that's going to get called. And it does all the crazy stuff with the queuing that the informers need and sets up the listeners for you. And then down here, you can see an example of how to watch other things. And it's really simple now. You can just say watch and then give it the factory and give it a function to convert the key from the thing you're watching to the thing you're reconciling. So I'm just going to do one more thing here, kubebuilder-h. And so I'm just going to go ahead and run this now using, I'm going to do Bazel just because I like it. We have Bazel support. You can also use Go. But this is going to go ahead and compile the controller and install the CRDs and do all this stuff. And while this is getting set up, I'll just talk about some of the features that are built in here and why you might want to use this. So what I've demoed is like, wow, that's really easy to get started, but it does some pretty advanced stuff. It does some advanced stuff like installing RBAC rules for you, creating reference documentation, and all that sort of stuff. So in another tab, which you can't see, I'm going to create one of these things. You can see in the tab you're looking at, it just ran the reconcile loop. So you can see that's running there. It's running against Minikube. And so that's your whole thing. You just got an API that's empty, and you can just start dropping in your schema wherever you want. Some things that you might find interesting is it generates these Docker files, and one of them is an installer. And the installer will create a container that will install the controller, install the CRDs, install the RBAC